Linux systems. There we have quite similar tool known as yeah, I think I messed up the password. The known as Hydra. Hydra. So the usage is quite simple. You can use this usage. Let's say Hydra, same way, -L, the username. Let's say admin, right? And then password, simple P. With simple P, you can try out password. Let's say the password you are guessing is QWERTY, right? QWERTY at 123 is the password. And then you can say, okay, FTP, your service is FTP 192, something like this. You can do that. If not, you can use password files. Only change is you are just specifying with big L or capital L. Then you need to specify your password list. Let's say root, right? Root, desktop, and then my username is user.text, right? And then the password list, if you have password file, you can say with the big P or a password file. Now we are going to give a password list here, right? And then you are specifying the service. And also you can find Hydra -GTK. That is the I don't know what happened. Sorry. All right. All right. So Hydra G. Oh, Hydra, I think GTK. All right. Let's go and have a look here. Applications, Linux, password cracking, offline attacks. Yeah, Hydra GTK. This is the one. So this is actually GUI version. If you are not very happy with passwords, command line, then you can specify the target like this. And even it supports IPv6 and protocol. It has a range of protocols, more than our Brutus. And whether it's SSL and the password list, you can use password list here. And password list, you can go and specify password list in a file, right? So you can do this, right? So right, you can be specific over certain LDAP. So right, so SNMP, SMB. You can be specific, and output will be shown here, and you can save the output here. You can start it, right? So it is quite similar to the previous one, right? And the next thing I want you to understand is when it comes to passwords, passwords are not usually saved as a plain text. Let's say my username is, let's say, administrator, right? My password is QWERTY, right? Now, most of the systems, they will not save this password as a plain text. Instead, they will use hash. What is hash? I will explain this hash and the cryptography module, right? So because I need to, I don't want to just jump into that. But as of now, hash is a fixed length data stream, right? Now I'm going to use Hashcalc, right? Hashcalc is a free tool where you can generate plain text to hash file. If I type QWERTY, right? So these are actually algorithms, right? So I will explain, in detail under cryptography module. But as of now, I just want to show you how passwords being saved. So usually MD5 is the mostly used password hashing algorithm, where if I calculate, it would provide this. So it will be always fixed length. Now QWERTY is the password, but it's being saved as a hash. Okay. Now, having said that, if you are saving your password as a hash, how system then verify the next time? For example, Windows systems, right? So we create a user, specify a password, and password being saved as a hash. What if the next time user provide, we always provide the the plain text one, right? So we don't provide this hash one, but we provide, let's say, QWERTY. Press enter. The thing is, if you know that, you will laugh sometimes. Our Windows systems have never ever saved our password in our systems, right? They always save hash, right? Now, whenever we enter password, password will be sent to a function called hash, will be converted to hash, and hash is being saved. That's what happened, right? And then next time, whenever you try the password, again password will be sent through a hashing algorithm, get the hash, and hash to hash compare. That's the reason our passwords are extremely sensitive. I'll show you how, right? So if you go here, QWERTY, let me make this Q capital Q, right? Only single letter. If you calculate, let's see the MD5, right? This is the output. You would see, right? MD5 is drastically changed. Even you can't find any matching character here, right? So the size is same, but outputs are completely different. So that's the reason our passwords are extremely sensitive. Not only case sensitive, it's extremely sensitive in all the possible ways, right? So capital to simple, any small change. Now let's say if you just now if you change it to normal, the password, if you see this, again it generates the same hash, right? So hash is same. So that's how our passwords are working, right? I hope now you understand up to this point. The next one I want to emphasize is when it comes to password cracking. So I demonstrated two tools, Brutus and Hydra. Whatever the tool you use, the tool does two things, right? Can you tell me what are the two things? One is this is actually two step. Let me delete this one. Step one is, right? Step one is, now we use a password file, right? Password file, then again, hashed or unhashed? Unhashed, right? So it's a word list plain text. So what this tool does is, first step is take the word from the word list and convert to hash. This is the first step. Second step, step two, is comparing a hash with the password hash, right? So generate, now you take the first word, convert hash, compare it. Take this, if it is comparing, it found the password. Perfect, awesome. If not, go to the next one, next word, convert it, compare it, convert it, compare it. I'll ask you a simple question, right? So I want an answer from everyone. What would you think from the computer, from the time that it takes to convert a word to hash? Now, let's say in my case, my password is QWERTY, right? Now, according to the first step, it has to convert to hash, this point, right? The second one is comparing this one with existing one. Let's say my existing one is the password with capital Q, right? So let me generate this again. So comparing this one with this one, right? Two steps. I hope you understand. Tell me now, for a computer, this is hard or this is hard? Conversion or comparing? In other words, let's say you take time, it takes time. Let's say to complete two steps, it takes 10 seconds, right? What would you think? Out of 10 seconds, the more time takes to convert or compare. What do you think? All right, so let me give you two answers. Number one is you say that more time takes for conversion. Answer two, compare. What do you think? What is your answer? Conversion or comparing? Hello, I think two. Okay, Geet says comparing takes more time. All right, right. Okay. Yeah. All says comparing, right? Unfortunately, it's wrong because now by looking at this, you might be thinking it's huge number, right? And then again, we see this as ASCII characters, but it will be converted to binary. So it would be more longer than this, right? So if you take, it can be huge number of bits. Let's say for argument's sake, it's 32 bits. So comparing 32 bit to another 32 bit. I agree. If I ask this question from humans, comparing takes a lot of time. Now, in order to compare this, we take some time. But the reality is conversion takes more time because it has to send through an algorithm. In this case, MD5. It takes a lot of time. If you just go and have a look, how complex this MD5 algorithm is, right? It has to go through few cycles, right? Through various operators. It takes a lot of computation. So if you take out of 10 seconds, this comparison, it wouldn't take even 1 second, right? Just it's like 1/10, I think less than that. So conversion take a lot of times because it has to use an algorithm and wait until algorithm process completing, and then only it takes whole computation. But comparing these two, no matter how long it is, for a computer it's really easy, not like humans, right? It's like a bitwise stream of bits, just comparing. So now I hope you understand now. So it's a two-step process, and first step takes a lot of time, which is conversion. The second step takes less time, which is comparing, right? And then I told you, with the computation power, it can take up to few months to password cracking. But then set of security professionals and researchers, they found out a mechanism to reduce the time, to break password more efficiently, right? That is known as rainbow tables. Rainbow tables, right? So rainbow table is again very basic technology. What we do is, by using rainbow tables, we compute set of word list as a predefined or pre-computed hash table. Now, I was telling you that you can do brute forcing or word list, whatever you have. So you can generate brute forcing a stream, plain text words, and then according to rainbow table, it computes all the plain text passwords to a the ciphertext or the hashes. Now, when you use this rainbow table, we are no longer required to convert. It's already converted, right? Computed. Then the cracking is going to be so faster because you are just comparing with entire list with the password hash. Whenever it matches, it returns the password, right? So that is known as rainbow table. So there are streams or heaps of rainbow tables available in the internet, or you can generate by your own. There are certain tools like if you are using Win command line, you can use RTGen. It's a tool, a rainbow table generator. And also if you need GUI, you can use Win RTGen, right? So you can use these tools to generate rainbow table. Now I hope you understand what is rainbow table. Rainbow table is pre-hashed or pre-computed table. So it reduces password hacking time in a huge way. I hope you understand that, right? So this is about the password, just overview. Now let me just go and have a look there under our XP system. All right. Now I hope everybody knows where we store passwords. So it's true to all the system, even Windows 10, unless if you enable credential guard, right? So credential guard is enabled in Windows system now. So your password hashes will be stored in a virtual place virtually. So then it's hard to use this system. But let's see in Windows XP 2003 and 2012, all these other previous stuff. All right, so if you need to find out where password is stored, it's there. WinDir, WinDir is the environment variable that you can use whenever you type a percentage WinDir percentage \, which means Windows directory, right? And system 32, you have a special folder called config. So if you go in, you would see a file called SAM, right? A SAM. This is the one. So if you try to open it up, right? So using our notepad, because you can use notepad to open almost. So it says it's being blocked or locked by another process, which means as a security precaution, main process of Windows, which is known as kernel 32, block this process, block this file. So you can't view it, right? So when you can't view it, you can't see what's inside it, right? So now let's see if there are any other methods that you can view the file, right? We are going to steal this SAM file. SAM is security account manager. In Windows systems, they use this file to store your password, right? Now, first, I would like to show you my user structure here. If you go in, you would see under users, you will find set of users. I have administrator, Brittany, Debbie. I don't know who has created these names, right? So, however, I have a set of users. Now, there are certain tools where we can dump this password file, because Windows use something called what do you call this? The make now earlier pre-Windows system, Windows systems earlier, when it comes to taking backups, it was not so easy. The reason was whenever you open a file, it's loaded to memory. So then you can't take a backup while file is open. To fix this, Microsoft has released a method called VSS, shadow copies, right? Virtual shadow copies, right? So because of that, any file can be accessed while it's open. So in that way, even file is open, you can take backups. All right. I hope you understand that. And we use this technique to dump this file, because even file is locked, there are certain ways that you can access the file. Let me show you how. Let me open up my command line here. Right, let's say, right. So you need this admin rights. So let's see later without admin rights how to access this file. But as of now, let's use this May. And if I go to see, there's a folder called tools. There I've got file called FGDump. Right, so FGDump, it's a free and free tool. I'm not sure whether open source or not. It's a free tool you can download from internet. You have multiple tools to do that, right? So if I show you a set of tools, sorry, you can use PWDump, you can use SAMDump, you can use FGDump. So all these tools can be used to dump a password. Let's go there. Right, now I'm going to do it's really easy. I'm just going to run FGDump. That's it. Now it dumps the password. You would see total successful and all that. And I'm going to open using Notepad 127, this file, this one. Open up. Yeah, this is my password file. If you remember the usernames, let me make it bigger a little bit. Right. So this is my password file. Let's make it a little smaller. All right. So here you would see, if you notice, administrator, ASP.NET, Brittany, Debbie, or you remember all these names, right? So now we have a number here. What is this? This is actually a unique number generated by Windows system to specify this user. The reason is smart administrators are changing the username. How to do it? Go to manage. Here, expand this user administrator. I can go here. I can rename the administrator to something. So by that way, we can just sort of confuse these password crackers, because it will try to crack a user called administrator at once, or even malicious codes like worms and viruses can try to do the same. So because of that, it's secure to change the username, right? Because we try to crack using username and password combination, right? So if you do that, this will be changed. But remember, in Windows system, if any account has 500 as a unique number, that is the admin account. That is the default created admin account. And guest always would be 501, right? So some smart administrators, they change administrator to guest and guest to administrator, right? So then usual general password cracking tools wouldn't work because they will try to crack administrator, but even crack it, they will have very low access. Sometimes it's disabled and all sorts of stuff, right? So, and also you need to remember three things out of those. 500 is administrator, 501 is guest. Anything created after installation is completed will have over 1000 number. So now something like this: 1012 Monica, Wayne is 1005, 1011, 1009. All these numbers created after the installation. It can be automated. Now, for an example, ASP.NET has created ASP.NET is automatically created when we install some additional tools. These are that. And then there are two range, right? So if you look at this, so this is my password hash. This part is known as LAN hash, local area network or LAN manager hash. Other one is NT hash, right? The reason is previous operating system before Vista was using LAN manager, but LAN manager was less secure because the thing is the algorithm that it uses is if it is less than 7 characters, it always add a same set of characters to make it 14 characters. So it has a very same the technology or method or algorithm to fix it. So it's easy to crack. So then Microsoft introduced another hashing algorithm called NT hash, right? So and now the systems, in order to do in order to support previous operating systems or backward compatibility, we have both. So LAN manager hash and NT hash, right? So if you notice, let me check one of the, yeah, right. All right. So if you check Monica's, right, this one and Teresa's this one, right? So what you can say, let's say Monica's and Teresa's passwords, what you all can say, right? By looking at this, what you can say about Monica's password and Teresa's password. Hashes are same, right? Which means passwords also same, right? So Windows systems, we have exactly. Yab is correct. So if you see something like this, you can say that, okay, these girls are having same password, right? That's possible in Windows systems. Unfortunately, even up to now, that's the case. Okay. Now we are trying to understanding and analyzing these stuff here. And if you look at now, this is where we store passwords in Windows systems. If you look at Linux system for a second, let's go and have a look at our Kali system. Let's go in here. Let's see how Kali stored the password. Right? There is a file called, let's say, leafpad. I'm going to use this editor and etc password. This is where Linux systems keep their information. You see the number of users that I have, root, right? So this donates the home folder and shell, default shell, and the group that I'm a part of. Here I have there are certain other users as well. The number of users I have created time to time, but you have not noticed the password here. Password denotes this part, right? X denotes the password. Username is this, password is that. What happened here? The reason is Linux systems, a bit smarter, the way they handle stuff, they keep something called etc shadow. The password file is different. So this is my password file. In root, this is my username and this denotes my password, right? Right. So this is the password. That is number one to remember, right? Okay. So I have only one user here. Now, here we have a few dollar marks, and then now if you notice this, now let me just make it a little bigger font, let's say 14, right, and make it bold. Okay. All right. If you look at here, let's focus on the first one. Now here we have, I don't know, I messed it up. So I have one value here, and then within this $2 we have another value here, and after this dollar we have he, lengthy, the character stream. Obviously this should be the hash, right? Then what are those? Now this first 6 denotes the algorithm. So in Windows systems, you have default algorithm, but in Linux system, you can decide whether you want to use MD5 or SHA, something like that. So this denotes that. The number denotes the hashing algorithm. Then what is this part? This is known as password salt. Password salt, right? So let me just word it here. Password salt, right? Now, as Yabi said, by looking at two password hashes, you can differentiate or you can find out similar passwords. And Linux systems, they use different technology called Salt. And remember, Linux, Salt is not available in Windows, only Linux. What they do is they don't want to have this it's not a vulnerability, actually, the method, like, they don't want if somebody access this Linux password database and to see, all right, Yabi and Upendra is having same password. They don't want to do that, right? So they use something called password salt. The technique is very basic. Now, let's say you have same ingredients to, let's say you are going to make a dish, right? So Yabi and all of you are making a dish, and you are putting same ingredients, something like our password, like same password. But by changing the amount you put or amount that you use salt, it change entire taste, right? So let's say dal curry, you're trying to make a dal curry, and Yabi is putting one tablespoon, and our Upendra is putting another amount. That can change taste entirely, right? So just remember that, right? Nothing to do with dal curries in this one. But what it does is it changes the hash. Now, how it works? Now, let's say whenever I create a user, let's say I'm going to create a user called Kushanta. The moment I create a user, it generates a random number. Let's say the random number is this, right? This is the random string, right? This is known as password salt. So whenever I create a user, it generates just a random number. Now, when I enter my password, what will happen is Linux system takes this part, right? Let's say my password is QWERTY, right? Linux system takes this part here, right? And then this part here, and then concatenate these two. And now it uses this entire word to generate the hash. All right. Now this is my hash. Sorry, this is my password hash. All right. Let's say I create another user called Yabi. Whenever I create a user called Yabi, Linux system generates a Linux system generate again random key, right? Unfortunately, Yabi also uses the same password. All right. Now what will happen? Now it takes Yabi's string here and then takes the password here, concatenates, and then generates the password, right? So now the password would be this, right? So it's a simple technique, but it still works, right? Now in Linux systems, we can't decide the password by just looking at hash, right? That is the moral of the story. Now, then how it works whenever you try to log in? It's simple, right? So whenever I try to log in, I'm just typing my password in the password box, click OK. System automatically gets my salt value from my password file, concatenates, hash it, and verify it. Then this is how it works. So this is where you can find my salt here. This is my salt. If I create another user, user will have another, random number as a salt. So that will be concatenate before they run this, right? So I hope this is clear up to now, Linux system and Windows system both. All right. Now let's go to our Windows system again, right here. All right. So now you know how to use it, and then I would like to show you a very interesting tool called Opcrack. Again, a free tool, right? Freely available one. And what you can do is you have few options. The one is you can use single hash. If you want to crack a single hash, you can use this option. And there is another option called password dump file. If you use PW dump file, you can use it. And encrypted SAM, you can use encrypted SAM file. And also it has inbuilt set of tools where you can use them. If I click on that, it can straight away dump my passwords, right? So these are the passwords. So we didn't have any administrator rights, just run the tool. It retrieve these passwords. And this is really interesting tool. Remember, I was talking about something called what do you call this rainbow tables. If you go to Opcrack, it uses rainbow table. In that way, it increase the efficiency in a high level. If I go to Opcrack tables, right? So you'll be redirected here. Opcrack tables. Here we are. You can find number of tables, rainbow tables in this range. So you can download a table with 17 GB, right? It's a table. You can download 17 GB. So brute forced, brute forced word list, respective hashes. Right? So it will have two brute force, word and the hash, right? So what it does is it compare the hash. When it find a match, it will return the password. All right, it's really easy. That's what it does. So you have different type of tables to download. So what you can do is when it comes to Opcrack, right here, you have option called tables here. So if you go into once you install Opcrack, you need to go to the location. Sorry, not location. Yeah, find the rather there. Location is that. There you have folder called tables. You need to download this, right? Sorry, you need to download tables. Where are my tables? I think okay. So you need to download this table and extract to this table folder. So I have done XP free. It's a very small table, like 700. I think 350. 380 MB, smallest one. I just want to demonstrate it. Once you download it, you need to go to Opcrack tables and you need to say install. Right? You need to install and then you need to show the table and it will be installed. I have installed only this table, right? But if you want, you can install everything here and it will be more efficient. Now, cracking is really easy with the rainbow tables. What you need to do is just say crack. Now it start using my tables and you would see LN password, LAN manager password and NT password that I was talking about. And you would see in a very limited amount of time, all passwords being cracked. And you would see the length of password. It's not very simple password, but still this tool can, perform this and break the password. I think you understand that. Still, we are in password cracking, and in the systems that we have access, we are going to break it. So after lunch, let's see if there are any system that we don't have physical access, how to do the same thing. And sometimes we forget passwords. And if you have physical access, what are the other methods that you can use to break passwords? So these are the things that we're going to discuss after lunch. The time is 1:25. And if anybody has any question, we can use this time to discuss or answer. Time is 1:25, so we have 5 minutes. If you have anything, you can share any suggestion. You are welcome. and any concern, anything you would want from my side to work on this. And then finally, we will be doing these labs also today. And I would like to talk about a special area along with this. Actually, it's supposed to be spoken during web hacking, known as Metasploit framework. Right? Metasploit framework is a framework that can be used by hackers. It will be installed inside the Kali. We're going to use that as well, right? So that's the plan for after lunch. If anything, we can discuss. Anything, Yabi, Upendra, Geet, and Tarumini.
Hello.
Hello, yeah, please.
Yeah, so one thing, is there a way to crack the password from remotely?
Yes, there are so many ways, right? So we are going to discuss after lunch.
All right, okay, sir.
Okay, yeah. So remote in the sense, if you are in the same local area network, same LAN, how to do it? If user is nowhere to be seen, like some other country, then there are certain other ways that you can use. Like so, the main thing is you need to think in a different way, and we are talking about many options and possibilities, and then you can decide what to do. Again, remember this is actually learning process, and hacking passwords or whatsoever, it's illegal unless if you have consent, right? Please remember that as well. So any other questions? All right, it seems you don't have any questions, so let this run, and when we come back we can see what happens there. So we'll have a lunch break, so you must be hungry by now. For me, the time is 6 o'clock. It's not dinner time and not lunch time anyway.